You know, ever since we first looked up at the stars, we've had this one huge question, right? Are we alone? But honestly, that question has changed. It's become a lot more practical. It's not just if there's life out there, it's how in the world would we actually find it? Today, we're going to jump right into that debate. What's the best way to search for extraterrestrial life?
All right, so let's get right into it. The big question is this: how should we even start looking for aliens? I mean, we can't just hop in a starship and go visit. So our search, it's kind of passive. We're stuck here, basically, cosmic observers, just squinting at these tiny, faraway points of light, searching for any clue, any tiny hint that something's alive over there. But what kind of clue are we even looking for? So it really boils down to two main strategies that astronomers use. On one hand, you can look for what are called biosignatures. Think of these as the telltale signs of just basic biology. Like the oxygen in our own atmosphere, that's a huge biosignature pumped out by plants and microbes. Then, on the other hand, you can hunt for technosignatures. And that's exactly what it sounds like, signs of advanced technology. This could be anything from a radio message sent on purpose to, hey, even the pollution from some alien industrial revolution.
So, signs of alien life. Yeah, how do we spot them? Like I said, we're basically stuck in our cosmic backyard. We can't go visit these places. All we can do is look for the signatures life leaves behind, that mark that biology or technology imprints on its world that we can see from light years away.
Okay, NASA's billion-dollar bet. And yeah, this isn't just some fun theoretical debate happening in university classrooms. The scientific establishment has already put a massive bet down on one of these methods, a bet that's going to shape our search for life for the next generation. And just look at the scale of that bet. We're talking more than $10 billion. NASA's huge next-gen space telescopes, missions like HABEX and LUVOIR, they're being built with one main goal: find biosignatures on planets that look kind of like Earth. And what about missions for technosignatures? Well, they're not even on the drawing board.
So that brings us right to the heart of it, doesn't it? Is this the right bet to make? Is this overwhelming focus on biosignatures really the best strategy? I mean, are we putting all of our cosmic eggs in the right basket here? To figure that out, we've got to find a way to compare them, head to head.
All right, let's do just that. Let's set up a kind of cosmic scorecard. We're going to pit biosignatures and technosignatures against each other on three really crucial criteria and see which method actually comes out on top. First up, criterion number 1, frequency. The argument here is super simple, and it makes a lot of sense. Intelligent tool-using life is, well, it's a specific kind of life, right? So if life itself is rare, then intelligent life has to be even rarer. Simple biology should just be way more common out there in the galaxy.
And you know what? On this point, you gotta give it to biosignatures. The logic is pretty solid. I mean, sure, you could imagine some super advanced civilization spreading technology all over the galaxy, but that basic idea that simple life has to come before technological life, that's tough to argue with. So point 1 goes to biosignatures.
Okay, but what about ambiguity? This is a really important one. Let's say we actually find a signal. How sure can we be that it's really from life and not just some bizarre natural thing that we don't understand yet? This is like a huge deal.
And this quote just nails the whole issue. I would take a prime number sequence over an oxygen signal any day of the week. Think about that. A technosignature, like a laser beaming a string of prime numbers at us. It's basically undeniable. There is no known natural process that does that. It would be a total, absolute slam dunk. Proof of intelligent life. Biosignatures, though, they have a major ambiguity problem. Take oxygen. Here on Earth, yeah, it's a sign of life. But we're now finding out there are tons of non-biological ways a planet could get an oxygen-rich atmosphere. You could have intense starlight splitting water molecules or weird reactions from hyperactive stars. It all depends on the specific chemistry and how much water the planet has. It's messy. So, when it comes to a signal that could be completely, totally unambiguous, you have to give the point to technosignatures. And just like that, the scorecard is tied, 1-1. Suddenly, this whole debate is looking a lot more interesting, isn't it?
All right, now for our final criterion, and this is traditionally the trump card, the most powerful argument in the whole debate: persistence. The question is, how long do these different signatures actually stick around? This is where things get really heated. Okay, so the traditional view points right back to Earth's own history. Our planet has been pumping out a detectable oxygen biosignature for something like 2 billion years, ever since the Great Oxygen Event. Now compare that to us. We've only been making detectable technosignatures, like radio waves, for about 100 years. That's a 20 million to 1 advantage for biosignatures. Seems like case closed, right?
Well, maybe not so fast. This is where we need to bring in a really radical new idea that challenges that whole assumption. What if our little 100-year window of technology isn't just a brief flash in the pan? What if it's the start of something permanent?
This idea is called the Great Awakening, and what it does is it reframes how we think about intelligence. It suggests that once intelligence emerges, it's not just a temporary civilization that comes and goes. Instead, it's a permanent phase change for the entire planet, kind of like how the Great Oxidation Event was for biology. Once that genie of intelligence is out of the bottle, it might be almost impossible to ever put it back in.
I mean, think about it for a second. Even if our current civilization collapsed, climate change, a pandemic, you name it, humanity is everywhere. We're survivors. We could probably persist in smaller groups for millions of years, evolving, branching out. So who's to say that over these vast geological timescales, new technological civilizations wouldn't just rise from the ashes, over and over again, creating this repeating cycle of technosignatures?
And this idea just completely flips our timeline on its head. If intelligence becomes a permanent feature of a planet, something that lasts until its star makes it uninhabitable, well then, the potential lifetime of technosignatures isn't just 100 years. It's closer to 1 billion years. And all of a sudden, that massive 20 million to 1 advantage that biosignatures had, it pretty much vanishes.
So with this completely new way of thinking about persistence, we have to go back and rethink our whole search strategy. Let's take one last look at that cosmic scorecard.
Okay, so here's the final tally. Biosignatures, they still win on frequency. Technosignatures, they definitely win on ambiguity, the potential for that slam dunk signal. And what about persistence? Well, biosignatures probably still have an edge, maybe something like 3 to 1, but it is a modest win. It is nothing like the knockout punch it seemed like before. So what's the big takeaway here? Look, searching for biosignatures is a great idea. It's a fantastic approach. But our scorecard shows that these two methods are way more evenly matched than that $10 billion investment in just one of them would have you believe. I mean, if we're willing to bet that much on biosignatures, it seems totally logical to invest just a fraction of that, maybe $1 billion on a dedicated mission to find technosignatures too. We should diversify the search.
And that really leaves us with one final profound thought to chew on. When we look out into the cosmos, are we just searching for these brief, fleeting moments of civilization? Or are we actually looking for planets that have gone through a final, permanent transformation into a technological world? The answer doesn't just guide our search for others, it really forces us to think about the ultimate fate of our very own planet.